Hi guys, it's Penguin Design here with another tutorial on how to make a video game. This time we're going to be learning how to make crossy roads. Now you're probably asking yourself, why specifically crossy roads? Well, there's a few reasons. One of the reasons is that, as you can see, the assets used are relatively simple, but still give us the opportunity to learn how to use a 3D modeling environment such as Maya. Second of all, the game's coding is very simple. It resembles the Atari 2600 Frogger. So, this will give us a perfect opportunity to learn how to code, how to make 3D models, and how to put a whole game together. So to start with, we're going to make what's called a prototype in Unity. So this is where, instead of having fully 3D assets, you just have simple cubes. So in this part, we're going to make a cube that bounces around with an animation. So first, we're going to open up Unity, and if you haven't checked the Unity website, Unity 5 is available for free. So you're going to click Create New Unity Project, and you can call it whatever you want. I'm going to call it Crossy Road. Select your file location and make sure it's 3D. Don't worry about importing any assets and just hit Create Project. So now, with Unity 5, you'll see there's a default skybox, but for this particular game, we don't actually use a skybox. So you're going to click on your main camera component, and then under Clear Flags, choose Solid Color. Now choose whatever color fits well for you. I personally prefer a nice turquoise. Now what you're going to do is create game object, a 3D object, a cube. Now under your main camera, set its rotation to be isometric. For video games, this is generally 30 on the x-axis and 45 on the y-axis. You should now be able to set its z-axis to 0. Currently it's using perspective, but in actual fact we need an orthographic view. As you'll notice, it's cutting up parts of the shape. In order to fix this, change its near clipping plane to -1000. Once this is done, you can rotate the directional light however you want so the lighting looks appropriate for your circumstances. I think the default looks good. Now what we're going to do is in our project window create a folder named Materials. In this materials folder, create a new material called Sample Player. The reason I'm using sample before it is because this will not be our final player's material, just our prototype player. Now under shader, you're going to check legacy shaders and then diffuse. Now choose any color that seems appropriate to you. I prefer a light red, but it's up to personal preference. Now drag the simple player onto your cube in the scene view. It should now be textured in both the game and scene view. Now in your project window, right click and create another folder. Call this Scenes. Now that we've set up the basic environment for our prototype, we're going to click File, Save Scene As, navigate to your Scenes folder and call it Prototype. Now, whenever you close Unity, you'll always be able to open up the prototype level and continue working on it. We're now going to create another folder called Scripts. This will hold all our code. Double click on the Scripts folder, right click, Create, and we're going to be coding in C# today. You can call this whatever you want, but I'm going to call it Bounce. This will be in charge of moving the player. Double click on it and it should open it up into a program known as MonoDevelop. MonoDevelop is an IDE that enables you to edit the text files of code. But before we do that, we're going to go to our cube and rename this to Player Object. Now you're going to Game Object, Create Empty, or Ctrl-Shift-N. Now call this Parent Player. Drag the player object onto Parent Player. Now that that's done, create a new empty game object and call this Level. Now you can drag the main camera and directional light onto this level, so now everything's neat and tidy. So before we begin editing our bounce script, under our parent player, drag on the bounce script. Now that we've opened up our bounce class in MonoDevelop, you'll see a few things. Initially, the Using Unity Engine and System Collections. Don't worry about this, we won't have to change it. Now the public class bounce extends mono behavior. This is just telling Unity 3D what our script is called. You will see inside it the void start and void update. The void update is called every frame of your game, and the void start is called when your game begins. Before we can begin in these void start and void updates, we're going to have to create a few variables. So first we're going to create a float named lerp time. This will control the period of time from the object moves from point A to B. Now I'll create a float called current lerp time. This will show where it is currently as it's lerping. And finally we'll create one more float called the percentage that's done. So I'm just going to call this pers. And set this equal to 1 just to begin with. Now that we're done with our float variables, we're going to go onto vector 3s. A vector 3 stores a 3D position in the game. So we're going to create 2. This is the start position and the end position. So what we can do is we can just copy our vector 3 start position, paste it on the line after, and rename it to end position. Now we've created all the variables that we need for now, but I'm sure we're going to have to add some later. So we can begin by deleting our void start. Now that we're in our update method, we can start coding. So first thing we're going to do is check if the player uses any of the arrow keys. So to do this, we're going to write if, and in your brackets you're going to write input dot get button down. Make sure to use get button down or else this whole thing won't work. Now in your brackets create 2 quotation marks and call it whatever you want in here. I'm going to use up because it's easier to use. Now we're going to write or, because we want it to be if they use the button up, down, left, or right. So to use or, you press shift and the backslash key. It should create 2 straight lines. So what we're going to do is repeat this process with up, down, left, and right. See you when I'm done. So now that we've checked if they've pressed any of the required keys, we're going to check if percent is equal to 1. What this will do is make sure that the cube has reached its target position. So we're going to write pers equals 1. That's why we set it to 1 to begin with, so that on the first time it calls this function, it will execute this if statement. So in this if statement, we're going to set the values for all our variables. So lerp time is going to be equal to 1, current lerp time is going to be equal to 0, and that's it for now. So now outside of these if statements, what we're going to be doing next is setting our start and end positions. So to set our start position, all we have to do is say start pos is equal to game object. Make sure to use a lowercase g. The difference between the lowercase g and the capital G is that the lowercase g is the game object that this script is applied to, and the capital G is any other object, including itself. So we're going to go game object.transform.position. We're going to write a semicolon to tell the computer that this line is finished. Now we're going to set our end position. We're going to do this by using a variety of if statements. So our first if statement will be if input .get button down is equal to right, and using a double ampersand, the game object with a lowercase d .transform.position is equal to end position. This will make sense later. Now in this if statement, we're going to set end position to be equal to a new vector 3. That means a new point in 3D space. And we're going to set the vector 3 x, y, and z coordinates to be transform.position.x plus 1. And this means that when they press the right arrow, it will make the end position equal to the transform.position.x plus 1. So now the others can just be left as they are. So what we're going to do is just copy this transform.position by using Ctrl+C and use Ctrl+V to paste it. Make sure to replace the second term of the vector 3 with y and the third term to be z. So now we're going to be doing a similar if statement 4 times in a row. So what we're going to do is paste that 4 times and replace these values as follows. We're going to go right, left, up, and down. So now we're going to set their corresponding positions. So left would be the same as right except with a negative value. And up would be changing it on the z value plus 1, and on the z value again minusing 1. Make sure to get rid of the plus 1 on the x-axis. So now that we've done that, we have set the now that we've set the start and end position, we're going to continue on. Now what we're going to do is make it so that the current lerp time increments over time. So we're going to say current lerp time plus equals time.delta time. Time.delta time shows the difference since the last frame. This will ensure that the game runs similarly on someone who has a computer that runs the game on 120 FPS, which means this void update will be called 120 times a second, versus someone who has a computer that can only run the game at 10 FPS. This will call the void update 10 times a second. So we need to ensure that the lerp time is affected by the frames per second of the person using his computer. Now we're going to multiply time.delta time by a number that feels right to you. I personally have found that 5.5 works. Now that we've made current lerp time increment, we're going to set the percent value to equal the current lerp time divided by lerp time. Okay. Now we're going to write game object, that means affecting this game object, dot transform dot position equals vector3 dot lerp. So now we're going to set the lerp values, and it's going to lerp from the start position to the end position by whatever the percentage is. We're going to save this code and cross our fingers to hope that it works. It's already giving us an error, so let's check what this is. It's saying that on line 41, character 17, you cannot implicitly convert a double to a float. What this means is we have to write a capital F after it to tell the computer that we want a float value. Save it, and Unity shall automatically recompile and check that this code works. What we're going to do is save our scene just in case Unity crashes because there's something wrong with our code. So when we press play, as we can see, there's already an error. We forgot to tell the computer what up, down, left and right mean. So to do this, we're going to go to Edit, Project Settings, Input. Under Axis, we're going to go 18 plus 4, which is 22. So now under all of these things named cancel, we're going to rename them appropriately. So we had up, and so this positive button will be up, and get rid of its alt positive. Name this one down, and its positive button is down. Get rid of its alt positive. Set this one to be left. Change its positive button to be left. We don't need an alt positive once again. And finally, rename this one to right, and its positive button to right, and delete its alt positive button. Press save with Ctrl S, clear our console, and press play. So now we're going to use our arrow keys, and as we can see, the character is moving, but it's not lerping as I would like it to be. So what we're going to do is maybe change the time.delta time to just be time.delta time and see how that works. I see why this isn't working. Just follow with me here. Now, under our variables, we're going to have to create two more variables. One of them called first input. So this will check if they've made their first input, semicolon, and the next one will be a public bool, and this will be called just jumped, or just jump. So what we're going to be doing later is implementing animations. So this jump is going to tell the animation when to trigger. So now, in our percent equals 1, we're going to set first input to be equal to true, and we're going to set our just jumped to also be equal to true, semicolon, to tell the computer that we're done with that. So now, down later in our code, with this block of code that's handling the lerping, what we're going to do is say if first input is double equal to true, then execute this code. So now it's going to check if first input is true and then start executing this code. So now, for animation, we're going to need to check if the percentage value is close to finished. So we'll say is greater than, say, 0.8. Now we'll set percentage to equal to 1. This will make it so that with Unity 5's new animation system, the script won't bug out. Now we're going to check if, when the percentage value is rounded up to the nearest integer, using mathf.round, it's equal to 1, then we can set just jumped to be equal to false. So this will work perfectly with our new animation system introduced in Unity 5. Let's give this a check to see if it's working. Press Ctrl S to save, and it looks like we have an error on line 57. Sorry, I meant only one equal sign. Now save using Ctrl S, go back to Unity, it should recompile, and now when we press play, hopefully it's working. That's working perfectly. Now we're going to add 2 more windows to our Unity editor. We're going to add the animator window and put this next to our game window and create another window named the animation window. So now put this near your console and project. This personally works for me, but you can put it wherever you want to. Now with our player object selected, we're going to, in our project window, right click and create a new folder and name this animation. Now in the animation window, once you've selected your player object, click on this little drop down menu and create new clip. Now name this clip whatever you want, but I'm going to name it jump. So this is the animation that's going to be played when the player jumps. So what you're going to do is go to the 5-second mark or so and make its transform components as follows. Set its Y position to 1 and its scale to 1.1. Now you're going to set its scale back to 1 and Y position back to 0.1. So now as you can see, our cube will bounce up and change in scale slightly. You can fine tune it to be a lot quicker or slower by selecting certain keyframes and moving them over. But personally, I think this will work properly. Now uncheck the record button and create new clip and call this idle. This is the animation that's going to be played when the character isn't doing anything. So what I'm going to do is go to about the 45-second mark and change its transform properties to -0.1 on the y-axis and 0.9 in scale. Now we're going to go to the 130 point, set these back to its default. Now if you play through this animation in the game window, you can see that it smoothly moves up and down, as if it was breathing. Now in our animator window, we'll see a whole lot of things have happened. So we're going to have to do a little bit in the animator window so that it corresponds with our code. We're going to, under our idle animation, click Make Transition and drag it up to the jump animation. Now under our jump animation, click Make Transition and move it to the idle point. Now under parameters, you're going to create a new parameter that is a type bool and you can name it whatever you want. I'm going to name it jump. What's going to happen is your code's going to make this parameter true when the character is just jumped, and then Unity will play the animation jump, and then once it's finished, go back to the idle. So with the idle selected, under our transition idle to jump, click the 2 little lines and we'll see a whole lot of properties. What you're going to do is adjust it so that the transition is almost nothing by dragging this until it says almost 0%. You can fine tune this as much as you want, but it's up to you. The most important thing is a condition. This will only happen when jump is true. So now, under our jump to idle, we're going to make it so there aren't any conditions, but we're just going to adjust the timing. So what I'm going to do is make it again 0, but make this near the end of the jump animation and the beginning of the idle animation. Our animations are designed so they don't need to be smooth in order to run properly. Once that's complete, we're done with the animator window and all our animations. Now in our project window, we're going to go to Assets and then Scripts. We're going to create one more C# script and then we're done. This is going to be called the Animation Controller. This is going to communicate with our bounce script and tell the computer when to play the animations. So drag this onto your player object. Double click on it and it should open with MonoDevelop. For this, we are going to be using our start function, but for now we can just get rid of these comments as they don't affect the computer. They are only seen by us. For this, we're going to define two variables. One of them is telling the computer what our animator object is. The second is a public game object that tells this script where the other object is that has the bounce script applied to it. We can name this the player, or whatever suits you. Now, in our void start, we're going to set the anim variable that we just defined equal to game object with the lowercase g dot get component. Now do two pointy brackets and set its component type to animator. Now use after this two brackets and a semicolon. This is how you get a component from an object. Now in our void update, we're going to get the name of this script. So write bounce. I'll now name this, for example, bounce script. And now set this equal to the player.getComponent. And now this time it's going to be called bounce. Semicolon. For now, we'll just press Ctrl S to save, and under our player object, we're going to drag in our parent object under where it says the player. Now we can go back to MonoDevelop and continue coding. We're going to create an if statement that says if the bounce script dot just jumped, so this is accessing the variable that we created in our bounce script over here, that's why we made it public, just jumped is equal to true, then execute this code. And that will be setting the boolean in our animator that we named jump to be true, semicolon. Now we're going to write else, so if this condition is not met, now set the animator.setBool and set the jump boolean, and now set this one to false in this case, semicolon. Hopefully that should be working perfectly. Press save. And I just remembered in our bounce script, this time.delta time is way too quick, so we'll times it by about 5. Press save, wait for Unity to compile. As you can see, we have no errors. Press file, save scene to make sure that, so that in case Unity crashes, we'll retain all our progress. I just remembered that for our idle, we need to make sure that it can execute the jump at any time, so uncheck has exit time. Now press play and hopefully that should work. As you can see, when we use our arrow keys, our player jumps, and when we're not, our player plays the idle animation. So you can tweak the values of the jump animation and the idle animation, but for now we've got all the code working. Thank you for watching, and in the next part we'll be creating a 3D model for the Crossy Roads character. We'll be using a program called Maya. I'll leave a link in the description for a place to download it for free that's completely legal. Thanks for watching, and please don't forget to subscribe and like.